Hey class, Mr. Moydian here with a calculus video talking about whether or not a function is continuous. Recall that a function is continuous at a point x equals a if the following three things are all true. The function has to be defined at a, the limit as you approach a has to exist, and as you approach a, you'll get the same number as you do at precisely a, meaning the previous two numbers will be the same. So let's dive in. This question asks, is this function continuous everywhere? Well, the only number that really is worthy of concern is 2, because anywhere other than 2, if I'm less than 2, I'm a straight line, continuous. If I'm more than 2, I'm a straight line, continuous. So the question is, what's happening at 2? Well, many things are happening at 2. Because depending on what direction I approach 2, I'm using different values, and at exactly 2, I'm using a different value altogether, a different piece of this piecewise function. So let's go through the checklist one by one. Is there a value at 2? Is f of 2 defined? Can I plug 2 into this function? It looks as though I can, because when f of x is 2, when f of 2 is being asked for, when x is equal to 2, the function rule spits out -4. So is f of 2 defined? The answer is yes, because I get -4. Next, is the limit as you approach 2? Does that limit exist? Well, what does it mean for a limit to exist? That means the limit as you approach from the left equals the limit as you approach from the right. So let's look at 2 from the left and 2 from the right. So from the left, numbers slightly less than 2, I would be using this top category. X is less than 2. So 1.99999, which is what this is implying, is indeed less than 2. So my problem becomes the limit as x approaches 2 from the left of the top category. For a limit problem, try direct substitution first, and if that fails, go on, but if it doesn't fail, that's your answer. So that's -3 times 2 plus 9. Now I know it's not exactly 2, but it's direct substitution. -3 plus 2 times 2 plus 9 would be -3, right? From the right, let's see what happens. So limit as x approaches 2 from the right, that's a number slightly more than 2, greater than 2, 2.0001. So using that category, that would give me 4x minus 5 as my rule. Try direct substitution, see what happens. So plugging it in, I get 4 times 2 is 8, minus 5, I also get 3. Does the limit exist? Yes, because I get 3 from both sides. The third and final question, which I can't fit on the screen. Is the limit as I approach 2, aka 3, equal to the value at exactly 2, aka -4? Are these two numbers equal to each other? Quite clearly you can see that they are not. These two numbers are not equal, and for that reason the function is not continuous at 2. The limit exists, 3. The function value is defined, -4. They're unequal, therefore the third part fails. Another example. Is this function continuous everywhere? Well, when x is not -1, it's a straight line, so yes. When x is -1, it's a dot, 9. The question is it continuous at -1? Because everywhere else, it'll just be this line right here, which is definitely continuous. It's a line. So let's go to the checklist. -1 is the only number we're going to focus on because it's the only number we need to focus on. Is there a value at -1? Is -1 defined? If I plug -1 into this function, is there an output? And the answer is yes. What's that output? It's 9. Because -1 is the only number in this category, and 9 is the direct output in that category. Next item. Does the limit exist approaching -1? Once again, you need to consider both sides. So the limit as I approach -1 from the left. -1 from the left is not -1. -1 from the left is not -1. It's a number slightly less than -1, meaning -1.0001. Not -1, meaning use the top rule. So that's 7x minus 3. Direct substitution, that's -7 minus 3. That's -10. From the left, I get -10. What about from the right? -1 from the right is also not -1. -1 from the right is -0.9999999. Very, very close to -1, but not -1. Once again, not -1, meaning use the top rule. Well, hey, I'm going to get -10 again. Does the limit exist? Yes, it does. That's a really ugly yes. Yes, it does. And it's equal to -10. So check, check. Step 3, which I might be able to fit, is the limit as you approach -1, aka -10. Oops. Don't know if this will be visible on my small screen here. Is the limit as you approach -1 equal to the value at -1? Are the previous two are the previous two numbers' results equal? This was -10. This was 9. Those are unequal, and therefore the answer is no. Unequal. Why? Because 9 is not equal to -10. So our actual question's answer, is the function continuous? It is not continuous at x equals -1. Hope this helps.